Theory of logarithms and laws of logarithms. A comprehensive exploration of logarithmic principles, properties, and applications in mathematical problem solving. What is a logarithm? Definition. The logarithm of a number is the power to which the base must be raised to give that number. If y equals n raised to the power of x, then x equals log base n of y. Examples: log base 10 of 1000 equals 3, since 10 raised to the power of 3 equals 1000. Log base 10 of 100 equals 2, since 10 raised to the power of 2 equals 100. Logarithmic form versus index form. Converting from index to logarithmic form. If we have an exponential equation like 2 raised to the power of -6 equals 1 over 64. Therefore, log base 2 of 1 over 64 equals -6. 3 raised to the power of 5 equals 243. Therefore, log base 3 of 243 equals 5. 5 raised to the power of 3 equals 125. Therefore, log base 5 of 125 equals 3. 10 raised to the power of 4 equals 10,000. Therefore, log base 10 of 10,000 equals 4. Converting from logarithmic to index form. If we have a logarithmic equation like log base 2 of 1 over 8 equals -3, therefore, 2 raised to the power of -3 equals 1 over 8. Log base 10 of 1 over 100 equals -2. Therefore, 10 raised to the power of -2 equals 1 over 100. Log base 4 of 64 equals 3. Therefore, 4 raised to the power of 3 equals 64. Log base 5 of 625 equals 4. Therefore, 5 raised to the power of 4 equals 625. Log base 10 of 1000 equals 3. Therefore, 10 raised to the power of 3 equals 1000. Evaluating simple logarithms. Identify the base and number. For log base 4 of 8, we need to find what power of 4 equals 8. Express as powers. 4 raised to the power of what equals 8. 4 raised to the power of what equals 2 cubed. Solve. 4 raised to the power of 3 over 2 equals 2 cubed. Therefore, log base 4 of 8 equals 3 over 2. Using this method, we can determine that the logarithm of 216 with base 6 equals to 3, and the logarithm of 0.0625 with base 8 equals to -4/3. Basic laws of logarithms. Product rule. Log of m times n equals to log of m plus log of n. Quotient rule. Log of m divided by n equals to log of m minus log of n. Power rule. Log of m raised to the power p equals to p times log of m. Special cases. Log of 1 equals to 0. Log of m with base m equals to 1. Log of 1 divided by m raised to the power n equals to -n times log of m. Change of base formula. Logarithm of n with base m equals to the logarithm of n with base a divided by the logarithm of m with base a. This formula allows us to calculate logarithms with any base using logarithms of another base. It is particularly useful when using logarithm tables or calculators that only compute logarithms in base 10 or base e. Applying logarithm laws. Example 1. Problem. Express as logarithm of a single number. 2 times log of 3 plus log of 6. Solution. 2 times log of 3 plus log of 6 equals to log of 3 squared plus log of 6 equals to log of 9 plus log of 6 equals to log of open bracket 9 times 6 close bracket equals to log of 54. Using the product rule of logarithms, we can combine multiple logarithm terms into a single logarithm. Applying logarithm laws. Example 2. Problem. Simplify. Log of 8 divided by log of 4. Solution. Log of 8 divided by log of 4 equals to log of 2 cubed divided by log of 2 squared equals to 3 log of 2 divided by 2 log of 2 equals to 3 divided by 2. This example demonstrates how to work with quotients of logarithms by expressing them in terms of the same base. Applying logarithm laws. Example 3. Problem. Evaluate. 3 log 2 plus log 20 minus log 1.6. Solution. Equals log 2 cubed plus log 20 minus log 16 over 10 equals log 8 plus log 20 minus log 8 over 5 equals log of open bracket 8 times 20 divided by 8 over 5 close bracket equals log of open bracket 8 times 20 times 5 divided by 8 close bracket equals log of 100 equals 2. This example shows how to combine multiple logarithm operations using the laws of logarithms. Practice problems. Simplifying logarithms. Simplify 1 over 2 log 25. Using the power rule, 1 over 2 log 25 equals 1 over 2 log 5 squared equals 1 over 2 times log 5 equals log 5. Simplify 1 plus log 3. This cannot be simplified further using logarithm laws. Simplify log 8 plus log 4. Using the product rule, log 8 plus log 4 equals log of 8 times 4 equals log 32. Evaluating complex logarithmic expressions. This example demonstrates combining the quotient and product rules to simplify complex logarithmic expressions. Problem. Evaluate log 45 minus log 9 plus log 20. Solution. Log 45 minus log 9 plus log 20 equals log of 45 divided by 9 plus log 20 equals log 5 plus log 20 equals log of 5 times 20 equals log 100 equals 2. Using known logarithm values. Given values. Log 2 equals 0.3010. Log 3 equals 0.4771. Log 7 equals 0.8451. Evaluate log 42. Log 42 equals log of 6 times 7 equals log 6 plus log 7 equals log of 2 times 3 plus log 7 equals log 2 plus log 3 plus log 7 equals 0.3010 plus 0.4771 plus 0.8451 equals 1.6232. Similarly, to evaluate log 35 equals log of 5 times 7. Since log 5 can be expressed as log of 10 divided by 2, we have log 10 minus log 2 plus log 7, which translates to 1 minus 0.3010 plus 0.8451 equals 1.5441. Solving logarithmic equations. Problem. Solve 2 to the power of 2x minus 10 times 2 to the power of x plus 16 equals to 0. Solution. Let y equal to 2 to the power of x. Then, y squared minus 10, y plus 16, equals to 0. Using the quadratic formula, y equals to open bracket 10, plus or minus square root of 100 minus 64, close bracket divided by 2, equals to open bracket 10, plus or minus square root of 36, close bracket divided by 2, equals to open bracket 10, plus or minus 6, close bracket divided by 2. Y equals to 8, or y equals to 2, therefore, 2 to the power of x equals to 8, or 2 to the power of x equals to 2, x equals to 3, or x equals to 1. Using logarithm tables. Convert to standard form. Express the number as a times 10 to the power of n, where 1 is less than or equal to a, and a is less than 10. Example, 37 equals to 3.7 times 10 to the power of 1. Find mantissa in table. Look up the mantissa, which is the decimal part for the significant digits. For 3.7, mantissa equals to 0.5682. Add characteristic. Add the power of 10 to get the final logarithm. Log base 10 of 37 equals to 0.5682 plus 1 equals to 1.5682. Similarly, for 3900 equals to 3.9 times 10 to the power of 3, log base 10 of 3900 equals to 0.5911 plus 3 equals to 3.5911. Calculating with logarithm tables. Example 1. Problem. Calculate 4627 times 29.3. Solution. Log of 4627 times 29.3 equals to log of 4627 plus log of 29.3 equals to 3.6653 plus 1.4669 equals to 5.1322. Using antilog tables, 10 to the power of 5.1322 equals to 135,600, 4 significant figures. Calculating with logarithm tables. Example 2. Problem. Calculate 819.8 divided by 3.905. Solution. Log of 819.8 divided by 3.905 equals to log of 819.8 minus log of 3.905 equals to 2.9137 minus 0.5916 equals to 2.3221. Using antilog tables, 10 to the power of 2.3221 equals to 209.9. This example demonstrates using logarithm tables to simplify division operations. Calculating with logarithm tables. Example 3. Problem. Calculate, open bracket 48.6, 3 times 8.53, close bracket, divided by open bracket, 15.3, 9 times 3.52, close bracket. Solution. Log of open bracket 48.6, 3 times 8.53, close bracket, divided by open bracket 15.3, 9 times 3.52, close bracket, equals to log of 48.63, plus log of 8.53, minus log of 15.39, minus log of 3.52, equals to 1.6869, plus 0.9309, minus 1.1872, minus 0.5465, equals to 2.6178, minus 1.7337, equals to 0.8841. Using antilog tables, 10 to the power of 0.8841 equals to 7.658. Practice problems. Change to logarithmic form. 25 to the power of 1/2 equals to 5. Therefore, log base 25 of 5 equals to 1/2. 0.01 squared equals to 0.0001. Therefore, log base 0.01 of 0.0001 equals to 2. Change to index form. Log base 3 of 1 equals to 0. Therefore, 3 to the power of 0 equals to 1. Log base 15 of 225 equals to 2. Therefore, 15 squared equals to 225. Evaluate using logarithm tables. 69.7 times 44.63 divided by 25.67. 17.9 times 3.576 times 98.14. 35.61 squared times 5.62 divided by cube root of 143.5. Practice questions. Question 1. Find the log of 802 to base 10 using log tables. Options. A. 2.9042. B. 3.9040. C. 8.020. D. 1.9042. Question 2. Find the number whose logarithm equals to 2.8321. Options. A. 6719.2. B. 679.4. C. 0.4620. D. 67.92. Question 3. What is the integer part of the log of 0.000352? Options. A. 4. B. 3. C. -4. D. -3. Question 4. Given that log base 2 of 1 divided by 64 equals to m, find m. Express in index form. Log base 10 of 10,000 equals to 4. More practice problems. Apply all the logarithm principles we have learned to solve these comprehensive problems. Problem 1. Evaluate using logarithm tables. Open bracket 6.28 times 304 close bracket divided by 981. Express your answer in the form a times 10 to the power of n, where a is a number between 1 and 10, and n is an integer. Problem 2. Use logarithm tables to calculate. Open bracket 6354 times 6.243 close bracket divided by open bracket 16.76 times 0.0323 close bracket. Give your answer correct to 3 significant figures.